All right, welcome back to the May 4th edition of I Can Science That. If you did not already take the quiz, please pop right up to this link here at the top. Go over, take the quiz first, and answer all 7 questions. They're multiple choice and true-false questions. And then come back here, and we'll do the discussion part. Okay, now that we have all answered the questions, let's go take a look and begin the discussion. The first question, acceleration is speeding up. And let's go ahead and talk about questions 1 and 2 together. Number 1, acceleration is speeding up. False. Number 2, speeding up is acceleration. True. And I get it, right? Yeah, I'm being cute here. Acceleration is literally defined as any change in velocity. In regular parlance, when we're just talking, we'll often use the word acceleration to refer to speeding up specifically. You have the gas pedal in the car is called the accelerator. The brake pedal is not called an accelerator, but under the definitions given to us for physics, in physics class, in a physics discussion, acceleration is any change in velocity. So that gas pedal, that's going to accelerate the car. The brake pedal will also accelerate the car. If you're traveling and you hit the brakes, you will suddenly slow down, and that is an acceleration. Also, the steering wheel, that will also accelerate the car. Any change in velocity is an acceleration. So acceleration is not specifically speeding up, but speeding up is a type of acceleration. Okay, hopefully that's very clear. Speeding up is one of the types of acceleration. Acceleration is not just speeding up. So number 1, acceleration is not just speeding up. Acceleration includes speeding up would be a good phrase, but they are not identical. All right, that brings me to question number 3. Speed and velocity are the same thing. Again, this is one of those common ways of speaking. We commonly refer to velocity and speed interchangeably in everyday language. But if we're talking about physics, if we're talking about anything in a physics context, we need to understand that no, they are not the same thing. This is false. Velocity is a vector. That means it has magnitude and direction. Speed is a scalar. It is not a vector. Speed has a magnitude but does not have a direction. So, just on that basis alone, they cannot be the same thing. More specifically, speed is the magnitude of the velocity. So, if we're going very fast in a particular direction, our speed is how fast we are going in that direction. And then we change direction when we go around a corner. We're still going at the same speed, but we're going in a new direction. Our velocity has changed, but our speed has not changed. So that's why it's important to know the distinction between there, specifically because in the context of this quiz, we're discussing acceleration. And remember, acceleration is not a change in speed. Acceleration is a change in velocity. So we could hold a steady speed as we go around a corner. You're driving your car and you go around a corner, holding a steady speed, and your velocity is changing because you're changing direction. That means you are accelerating. Going around a corner in a car is another form of acceleration. And once again, this is specifically in the field of physics, right? If we're just talking about regular folks talking, I think we commonly talk about the car's acceleration referring to speed going up. Like I'm accelerating if my speed goes up. But no, in physics, any change in velocity is an acceleration. And so honestly, if you're arguing with an AI about this, I think that may be the source of the argument. is what exactly do you mean? Are you speaking in terms of physics, or are you just talking about, regular speech? Lemon drop. If I drop a lemon from my balcony, it will accelerate downwards at a constant rate. That is true. Gravity is a constant rate of acceleration. We're neglecting a bunch of things. We're neglecting the air resistance. We're neglecting the inverse square law of gravity over these distances. We can consider, and we always do in these high school physics types of situations, we're going to consider the acceleration due to gravity to be a constant, steady acceleration. So when I drop that lemon, it will begin accelerating towards the ground. You've probably heard the term 9.8 meters per second squared, or 32 feet per second squared. The lemon will accelerate at a constant 9.8 towards the ground. That is true. So if it is accelerating constantly, is the speed of the lemon? Of course, it is steadily increasing. We are accelerating. The speed when I dropped that lemon started at 0. It was just holding still until I dropped it. And then it starts accelerating down. So that is a steady increase. The correct answer there, 5B. Okay. Now, the last question. I am hoping you will start to see how acceleration doesn't mean speeding up. With one more question. Here we go. If I throw a lemon straight up into the air, it will accelerate downward at a constant rate. That is, again, true. Gravity is a constant rate of acceleration, as long as we neglect, those smaller terms. So anything that is not being held up and is not having any thrust given to it, as soon as I let go of that lemon, no more thrust, it's just going to do what it's going to do. And what it's going to do is accelerate downward at a constant 9.8 meters per second per second. Okay, so if that's the case, then the lemon in this case, it starts going upwards at a certain speed, and then it's going to accelerate downwards. That's going to cause the lemon to slow down. When I throw it up in the air, it has a certain speed when it starts. It slows, comes to a complete stop as it reaches the apex, right? It's going to go as high as it's going to go, and then it's going to start falling back down towards the ground. So at first, it is moving upwards. It is slowing down under the acceleration of gravity. It then will come to a zero velocity, where it's just it's just holding still, a zero speed. And then it will come back down, accelerating downwards. So the constant rate of acceleration, does that cause steady decrease? No, at first it's going to decrease the speed of the lemon. Remember, the speed is the magnitude of the velocity. It's how fast is it going. So the speed is decreasing until it hits 0, and then it goes downward. And so we're not going to describe that as a negative speed or something. We're going to call that an increasing speed. Now the lemon is going to start increasing its speed towards the ground, right? First it was going away from the ground, slowing, and then speeding up. So the correct answer here for number 7 is C. So yeah, please do share this with Dearth and see if in the context of throwing lemons, we can understand what acceleration, velocity, and speed mean, and if we're being, strict and careful with our terminology, I don't think there's any need for confusion. This is stuff that we learn in physics, in the physics classroom and the physics textbooks, because this is the vocabulary as it is used in that field. I understand we commonly use these words in other ways. We refer to acceleration specifically as speeding up often, and we'll even say like deceleration. Deceleration would mean to slow down. We'll hit the brake and decelerate. But in physics, in the context of physics, that's all acceleration. In the context of physics, the meaning of acceleration is any change in velocity. So speeding up is a kind of acceleration. Slowing down is also a kind of acceleration. And changing direction is also a kind of acceleration. And bringing this back to our May 4th date, if you see a mass like a lemon and it is accelerating, that means that lemon is experiencing an unbalanced force. So yes, please do share this. Share this pair of videos, particularly the quiz one first with Dearth or Flatzoid or any other of the folks who like to argue about physics while not inviting like a physics teacher into the discussion. Maybe we can sort of smooth this all out if we simply understand that you can accelerate without changing your speed, because velocity is not just speed, it's speed and direction. So if you change your direction, that is an acceleration. You could also slow down. You could be slowing down, and that is also an acceleration. So putting that all together in the context of, arguing with an AI about whether acceleration can occur without the speed going up. Hopefully we understand now that you can. And that's what that means, because when we say acceleration, we do not mean speeding up. Okay, thank you all, and may the 4th be with you.